There's one star in our galaxy that keeps dimming in ways nothing natural fully explains, and scientists still haven't ruled out that something built it that way. At its deepest, its light dropped by more than a fifth in a single pass. Comets don't do that, and dust doesn't either. If any civilization out there ever built something big enough to bet on, this is exactly where you'd catch them red-handed. So keep that in mind, because we're ending there. This is the actual toolkit scientists use to hunt for someone out there, not ranking which planets could hold life, but actively listening, watching, and calling out for proof. In 1977, a radio telescope caught a burst so strong the astronomer reading the printout circled it and scrawled one word: wow. Frank Drake got there first in 1960, one dish, two nearby stars, a project named Ozma. Nobody has ever picked it up again. Not that telescope, not any other, not once in nearly 50 years of trying. Arecibo was the biggest ear on the search for decades, wide enough to swallow a stadium. For decades, the biggest ear in the search was Arecibo, a dish wide enough to swallow a small stadium. It collapsed in 2020 and went silent for good, taking one of SETI's favorite instruments down with it. Radio was always the obvious channel to check first. It slices straight through interstellar dust that would block almost anything else. Tuned near the hydrogen line, any civilization that's done basic astronomy would know to check there. Today, the listening happens mostly through the Allen Telescope Array and a project called Breakthrough Listen, scanning roughly 1 million nearby stars for one signal too clean to be natural. Every hit gets crossed off, interference, satellites, our own radio noise, before anyone celebrates. More wow-like blips have popped up since. Every single one turned out mundane on a closer look. Half a century of listening, across 1 million stars, and so far the universe has said back, nothing. A single laser pulse can outshine its entire host star, just for an instant, and that counts as a signal too. Optical SETI scans starlight for a flash brighter than the star itself, blinking on for a few billionths of a second. Far too short and far too precise for anything nature makes on its own. The searching happens through observatories like Lick, watching thousands of stars at once for exactly one flicker out of place. No confirmed laser signal has ever been caught this way, not once, across thousands of stars already checked. But the search keeps expanding, because if a civilization wanted to shout across the galaxy on a budget, light might be the cheapest way to do it. Here's where the stakes climb. Instead of waiting for someone to call, scientists started hunting for the mess a civilization leaves behind without meaning to. Certain manufactured gases don't occur naturally anywhere, so spotting one in a distant atmosphere would mean catching someone's factory exhaust from light years away. Waste heat works as a fingerprint too. Any technology anywhere has to dump energy it can't use. Thermodynamics doesn't care about your stealth technology. If you're doing work, you're leaking heat and someone can watch you sweat. Some of it hides in plain sight. Reflective solar panels, city grids, anything that changes how a planet reflects or radiates light. NASA has spent entire workshops just arguing over what a detectable technosignature would even look like. So far, zero confirmed pollution, zero confirmed waste heat around every star we've checked. Take that same idea and push it as far as it can go, and you get the most extreme version of it, an entire star's output, captured and reused. A message needs someone to send it. A footprint doesn't. It just needs a civilization loud enough to leave one. Dial back from intelligence for a second, because the hunt for life itself works completely differently through starlight filtered by a planet's own air. When starlight passes through an atmosphere, gases carve out missing wavelengths, like a barcode telling you exactly what's up there. Oxygen and methane are chemical enemies. Leave them together, and they cancel each other out fast. Find both at once anyway, and something has to be constantly replenishing them. Life is still the simplest explanation anyone has. Alone, oxygen proves nothing. Dead planets make it too, so scientists trust combinations, never one molecule. K218b made headlines in 2023, a proposed hint of a gas mostly linked to life on Earth, though later reanalysis of the JWST data cast real doubt on whether it was even there. Contested is the key word. One hint of a molecule doesn't confirm life. It just means the argument gets to keep going. The same test would catch Earth. By the way, our own oxygen and methane mix is exactly the kind of anomaly this method is built to flag. This method never calls out and never waits for a reply. It just reads a planet's exhale from tens of light years away. Then there's the option that flips the entire strategy on its head. Stop listening and shout instead. Back in 1974, Arecibo beamed a deliberate message at a star cluster on the other side of the galaxy. Encoded numbers are chemistry, even a sketch of us. METI, messaging extraterrestrial intelligence on purpose, no sign-off needed. No law on Earth stops anyone from beaming anything at any star they pick. Some scientists call that brilliant outreach. Others call it yelling your home address into a dark forest and hoping only the friendly ones are listening. Stephen Hawking warned against it, worried whoever answers might not be the neighbor we want. The program hasn't been canceled. Those messages are already crossing space at light speed, and there is no calling them back. Listening, watching, sniffing atmospheres, shouting into the dark. Every method so far assumes we'd even recognize the answer if it arrived. Underneath every one of these tools, the same pattern is hiding. Radio dishes, laser detectors, pollution scans, biosignature spectra, even the messages we've sent out. Every one of them shares the exact same blind spot. They only catch civilizations that broadcast, leak, or reply, using energy and chemistry like our own. None of these tools were built to notice a civilization that's gone quiet on purpose. A civilization a million years ahead of us might not leak anything at all. It might not use radio, might not pollute, might have engineered its own waste heat away entirely. So the only kind of alien intelligence our current toolkit can actually find is one that's still sloppy enough or young enough to look a little bit like us. Which brings us back to the strangest star in the search, the one that opened this video, and the one candidate that doesn't fit that pattern at all. Citizen scientists sifting Kepler data flagged Boyajian star. It dims and brightens like nothing else out there. Its light drops by more than a fifth at the deepest point, and comet swarms, dust clumps, even a broken moon have all been proposed. None fit perfectly. One hypothesis still stands: a Dyson swarm, structures built to drink a star's entire output. Picture it: instead of one small planet catching a sliver of its star's light, thousands of collectors ringing the star itself, catching almost every photon before it ever escapes into space. Freeman Dyson said it first in 1960. Keep growing long enough and you outgrow your planet, then build around your star. Other surveys scanned hundreds of thousands of stars for that telltale infrared glow. Nothing ever held up. If something like that existed, it wouldn't glow at radio frequencies, and it wouldn't blink a laser. It would just quietly block a slice of starlight passing by. Exactly the kind of signal none of our other tools were built to catch. That's the twist. The most extreme candidate humanity has ever found didn't show up on a telescope built to listen. It showed up as an absence. Follow-up surveys studying the star's light have found other explanations, mostly favoring a cloud of orbiting dust or the debris of a shredded object. Dust clouds have dimmed other stars this way before. That's why researchers reach for it first. Most astronomers now shrug toward one of those natural answers. But the case isn't fully closed, and after more than a decade of study, nobody has ever ruled out the stranger option entirely. Nobody's confirmed aliens are there. Nobody's confirmed they're not. That maybe is the closest thing to an answer. Somewhere between a wow signal that never repeated and a star that still won't explain itself. Humanity keeps looking anyway. Strip away the tools, and every method here is chasing the exact same question. Are we the only ones who ever looked up and wondered the same thing? Right now, every one of these searches is still running, still checking, still finding nothing definitive, and still not finding a reason to stop. In a galaxy this big, silence this consistent is its own kind of clue. If a civilization that advanced ever solved interstellar travel instead of just broadcasting, here's exactly how far physics says they could actually get. Subscribe because that's the next video. How far an alien civilization could really travel and what would stop them.